Alright, here is a problem that will give us a little bit of practice with the quantum numbers. And so here it says, which of the following sets of quantum numbers is or are not permitted? Okay, so I think the analogy, if we have that in our mind that I gave, would be useful here. N equals 3, all right, there's no problem with the n as long as it's from 1 or above, that's fine. L equals 0, so that's like the S wing, right? M sub L is positive 1. Okay, now here we run into a problem. Okay, in the S wing, or when L equals 0, there's only one door at the end of the hallway, right? So that door is given the number 0, and there's no plus or minus 1, all right? So this one won't work. All right, so now n equals 3, L equals 2, okay? On the third level, there's the 0, 1, and 2 hall, okay? So that's the S, P, and D wings of the hotel, if you will. That's fine. And when L is 2, that's the D wing, and there's the 0 door at the end, and then there's 2 sets of doors on either side. So 0 plus and minus 1 plus and minus 2. So minus 1, that's okay. M sub S, okay, minus, no, M sub S is always plus or minus 1/2, okay, so that one won't work either. Now n equals 3 again, L equals negative 2, no, that doesn't work. The hall number, if you will, is 0, 1, 2, etc. Starts at 0. No negative numbers are okay for that one. So that's out. And then n equals 3, L equals 3. Okay, here we have a problem also. There aren't that many wings on the third level, right? So as it turns out, none of these are permitted sets of quantum numbers. There's it doesn't work. Okay, so let's do a few other problems just for some practice. Okay, this one says, what values of M sub L are permitted for an electron with L equals 5? Okay, now that goes beyond what I drew in my analogy, but I think we can still think about it and get the answer. Okay, values of M sub L, that's the doors, the rooms, in each wing. All right, and we have L equals 5, so that's like hall 0, 1, 2, 3, 4, 5. All right, so we have 6 halls on that level. That obviously wouldn't be any of the first several levels. But it says, what values of M sub L? Okay, so let's think about this. And when L is 0, and the L equals 0 hall, there was just that one door at the end, the 0 door. In the L equals 1 hall, there was the 0 door, and then 1 pair of doors in addition. In L equals 2, there was a 0 door and 2 pairs of doors. So you see the trend. When L is 5, you're going to have the 0 door and then 5 pairs of doors, so a total of 11 values, 0, plus and minus 1, plus and minus 2, 3, 4, and 5. Those are the values of M sub L that are permitted for an electron with L equals 5. Okay. Now, how many different values of M sub L are permitted for an electron with? Okay. How many different values of M sub L? Here it's asking what are the values. Here it's saying how many different values are there. Well, there's 11, and they are the the 0, and then plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, and plus and minus 5. All right. So here we go. Here's another question. Arrange the following electrons, identified only by their n and l quantum numbers, in order of increasing energy from lowest to highest. Okay, so this goes back to the rule for energy of the electrons, which is n plus L. So we just add the numbers and we can arrange them in order of increasing energy, right? So the lowest energy is going to have the lowest values for n and L. So that would be this one, D. 5 and 2 is the lowest value among these four. And then we're going to have 5 and 3. Okay. Now, you'll notice 5 and 3 makes 8, and 6 and 2 also makes 8. So when, in a case like that, where we have two or more that are have the same sum of n plus L, we go with the one that has the lower, or the lower n has the lower energy. So here's the lowest, then n equals 5, L equals 3. Then we go up to n equals 6, L equals 2. And then n equals 6, L equals 3. That would be the highest among these four. Okay? And again, arranging in order of increasing energy. So the same rule, n plus L. So our lowest n is 4, and L is 2. So here, this one is the lowest. Again, we have these three all add up to 6. Okay, so the one with the lowest n, that's the lowest, and then we go up to the next lowest n. So 5 and 1, that's going to be next, then 6 and 0, and then 4 and 3. Okay, because 4 and 3 is 7, whereas these three are 6. Okay, so so the n equals 6 and L equals 0 is actually filled before n equals 4 and L equals 3. Okay. Arrange these in following of increasing energy, in order of increasing energy. We're again going by the n plus L rule, and you see right off the bat n equals 5, L equals 1 all across the board. So even though we have different values over here, all of these electrons have the same energy. Okay, if they're in the same wing on the same level, they're all equivalent. Okay, so regardless of what room they're in or what seat they're in, it doesn't matter, they have the same energy. Okay, so all of those are equivalent. And likewise here, we're comparing the energies. Well, they're all equal. They're all in the same wing of the atomic hotel. So they all have the same energy. All right. And here it says, again, arrange in order of increasing energy. This time we do have some differences. Increasing energy, so we're talking about increasing n plus L. And so our lowest value for n and L is here. 4 is the sum. That's the lowest. And then here we have 4 plus 0, so that's next. And then we go to the 5s, 3 plus 2, and then the highest in energy is the 4 plus 1. Okay? So hopefully that has been helpful in understanding the electron energies.